Hey guys, let's take a look at the following new video dealing with alcohol reactions. So here it says alcohols can be easily identified by the presence of the hydroxyl group, so their OH group. Because of the presence of this highly polarized group, alcohols can be involved in many organic reactions. So here we're going to take a look at the three major types of organic reactions that deal with alcohols. So we're going to say here, substitution. Under this reaction, alcohols react with the hydrohalic acids of HCl or HBr to become alkyl halides. All that happens in this reaction here is that the OH here will get replaced by the halogen in the acid. That's all that is occurring here. The OH in the alcohol gets replaced by the halogen. So what happens here is we have CH3, CH2, CH, the Br is going to be there now, CH2, CH2, CH3. And the reason that this happens is because what's actually happening is the OH and the H are combining and you're losing them as water. And so the Br lost a partner, that carbon lost an OH, so what do? They just meet up together and create an alkyl halide. Remember, an alkyl halide is when you have a carbon connected to a halogen. Here, the next type of reaction we can do is an elimination reaction. Under this reaction, under the presence of concentrated acids such as H3PO4 or H2SO4, an alcohol undergoes dehydration. So we lose water again. Now we're going to form an alkene. So we're going to form a double bond. So basically what happens here is, here's our acid, and usually it'd be good if we used heat. So this triangle here represents heat. What happens here is this OH is going to be lost, and then one of the neighboring carbons is also going to give up an H. So together they lose water. Okay, so this carbon loses a OH, this carbon loses an H, so now they're one bond short each. So what are they left to do? They form a double bond with each other, so that carbon still makes 4 bonds. Remember, carbon is tetravalent. It wants to continue making 4 bonds. So that carbon is going to double bond to this carbon here. And we have that. Now that carbon could have done it to any one of the neighboring carbons because they're all CH3 groups. They're all the same. The double bond could have been made anywhere around it. Now besides that, we also have our third reaction, which is oxidation. So in oxidation reactions, an alcohol can be seen as an alkane that has undergone an initial oxidation. The alcohol can then continue to be oxidized to form either an aldehyde, or actually not an aldehyde, either a ketone or carboxylic acid. Okay, this is done with the strong oxidizing agent sodium dichromate, Na2Cr2O7, and the strong acid sulfuric acid, H2SO4. Okay, there's also an inverse relationship that can change our products back into their reactants. So what we have here is a primary alcohol. Okay, and this primary alcohol, what's going to happen to it is, the primary alcohol, when we use these reagents, it changes the primary alcohol into a carboxylic acid. So that's what we would do. And we could say that there's an inverse relationship, meaning we can go backwards if we use a reducing agent, a strong reducing agent. And this strong reducing agent will be LiAlH4, which is called lithium aluminum hydride. So lithium aluminum hydride can take us back there. Also, we can say besides a primary alcohol, I could have used an aldehyde. So if that carbon had been an aldehyde, the same thing would have occurred. So this changes primary alcohols and aldehydes into carboxylic acids. Okay, so I'd still make that same exact compound. Now, a secondary alcohol, this one. So remember, we've talked about how to classify alcohols in previous sections. Here the carbon and the OH are counted as 1, and you say how many carbons is that carbon connected to? 2. That's what makes it secondary. Now, secondary alcohols can be oxidized into what? Into ketones. So basically, this carbon here changes into a ketone carbon. So it's going to form a double bond to oxygen. Okay, so it's going to lose its H so that it can make a double bond, and the oxygen is going to lose its H so that it can make a double bond. So secondary alcohols get oxidized into ketones. And again, there's the inverse relationship, where you can take the ketone back to the secondary alcohol if you use that strong reducing agent, LiAlH4. So here we're doing reduction going backwards, and to go to the ketone we oxidized. Finally, here we have a tertiary alcohol, because again, carbon in the OH counted as one group, and you say that carbon is only connected to 3 carbons, so it's tertiary. The thing about tertiary alcohols is tertiary alcohols cannot be oxidized. So you'd say here, no reaction. Only primary and secondary alcohols can be oxidized here. Tertiary alcohols cannot be oxidized. These are the different types of reactions that alcohols do at this point for you guys. Again, said it a million times already, when you get to Organic 1, you'll learn even further reactions dealing with alcohols. Here you guys are just getting a small sample of the most popular types of alcohol reactions.